Hello everyone, this is Algebra for Faith, and today's lesson is for May 13th, and we are starting on 11.5? No, 11.6. So 11.6 switches over the Pythagorean, so it's on page 457, and I'm just going to tell you, I think the correct enunciation for this is the one you would not think would be the enunciation, which is Pythagorean. I've heard it pronounced Pythagorean. I've heard it pronounced Pythagorean. So I don't really think it matters. The dude's name was Pythagoras. So I don't think it really matters. It's just an interesting concept that we've used on a lot of stuff. It should be a familiar concept for you because you should have learned this probably initially in the 6th grade. I know 7th grade goes over it, 8th grade curriculum as well goes over it. It's a very important concept that's used in a lot of different careers. I know people think that's crazy, but no, they do. So first of all, before we get into it, we're going to go over some lesson openers just so maybe you can get back in your brain how we use radicals. And so I've got just a few things for us to do, looking for something that will actually be a little bit different. Before we get into our lesson openers though, let's go to the Lord in prayer. Heavenly Father, we want to praise you and thank you for the many blessings you've given us and for giving us mathematical concepts that we can learn and define the world, that can help us build the world, or build things in the world anyway, because you created the world. And Father, we love you and we pray that you'll just give us all clear thinking and help us to learn what we need to know. We love you in Jesus' name, amen. All right, so going back to just making sure I understand the concept of radicals a little bit. So if I've got x equals the square root of 16, how would I solve that? Well, I would take the square root of 16, and I'm assuming, since I don't have anything there, I'm going to assume that's positive, so that would be x equals 4. Notice how that's a little bit different from the next one. Well, this one right here, I have a negative sign in front of it. So I would go ahead and solve the square root of 16, but keep the negative sign, so it's a negative 4. This is telling me it wants absolute value from the square root of 16. So when I solve that, absolute value would be either plus or minus 4. When you have a concept that looks like this is once again going to be absolute value because we actually had something that looked like this maybe in chapter 1 when we went through radicals, where I would solve that, and we'll go over this situation later, by basically putting both of those under radical sign. This would come out as x, this would come out as a plus or minus 4. Look at how this next one looks exactly the same. Wouldn't I solve that the same way? You would, except this time your problem is telling you it's length. We really don't have negative length. So if you're talking about length or a measurement, then you're going to automatically assume it's going to be a positive number and use the positive number, not try and come up with the plus and minus and all that. That's simply to get that a little bit into your brain. So if we go to the Pythagorean theorem over here, like I said, you have had this. It's very familiar probably to you. It's used in a lot of concepts. Just realized I did not turn on that other light. Hopefully that will not, can y'all see that? I guess, hopefully you can. I think I'm going to go turn it on. One moment. Oh, and I forgot to put up my recording sign too. I'm prepared today. All right, so I'm back. So the Pythagorean theorem is based on the right triangle. And a right triangle means it has a 90-degree angle in it. And that tells us a lot of things. If I can get it, the right triangle has two legs, A and B, which don't necessarily have to be the same length. But because of that right angle, I know if I square A and then add it to the square of B, then I will get the square of C. And C is the hypotenuse. That's always the side of the triangle that's opposite the right angle or the 90-degree angle. That's all that means. And we have used This triangle, since ancient times, since Pythagorean time, maybe before then, to be able to figure out exactly what the length is. And I just want to give you a concept, like somebody who's natural resources could potentially use this, get the shadow of a tree, figure out how tall the tree is. In engineering, you can figure this out for the bracing to figure out a tunnel through a mountain if I just add another side. But what a lot of people don't realize is that military, forensic science also uses too. Because if the guy got shot here, where could the murderer be? Oh, I could potentially find him through his trajectory of his gun, or where was he actually at? So Pythagorean, reverting back to my old enunciation, but Pythagorean is used in a lot of different concepts. It's very important for you to kind of get this in your brain a little bit, and especially since some of you will be heading into geometry next year, just to get a good footing on this. One thing that we already talked a little bit about in our lesson opener is, as we're going through it, if you look over here at the top of page 458, is what they call the solving of an equation that looks like this. Basically, that was me putting both of those under a radical sign. And then I took out x, I took out the square of x is x. This just remains c, except it remains positive or negative. It comes out kind of like an absolute value like we did earlier. Now, I'm not going to go through each separate thing, and we are going to solve a Pythagorean theorem here in just a second to figure out a right triangle. But the way your quiz is set up is we use a couple of different formulas prior to getting to that, and then we'll use this in order to figure out, is this a right triangle or not? So, moving over, first of all, I'm going to skip around on your page, is a formula that you're familiar with. You've actually used this before. And this is midpoint formula. This is where we use the Cartesian plane, where we drew lines and we used plot points. We had an X and Y, and we used midpoint formula to, if I had a line and all I had was a set of plot points, two X's, two Y's, exact points on that graph or that Cartesian plane that we've been using, how could I find the middle of that? So if I had the plot points, if I had the X and Y, how could I figure that out? Well, you would take your X's, you would take your Y's from that point, and that would give me the plot points. If I added them, divided by 2, added them, divided by 2, that would give me exactly the plot point of where on that line, it would be the exact middle of it. Like I said, you've used this before. Distance formula is a newer concept that you have not had before. Maybe you have, I can't remember. So distance formula is using those same plot points like we've had before, like X's and Y's, being able to plot stuff and make a line, or plot stuff and make a parabola. Well, distance formula is where I'll take those same plot points, and if I plug this in under a radical sign, then that's going to tell me what the actual distance is from this plot point to the next plot point. And we're going to use all of those in order to complete your quiz today. So if you have your quiz, remember we did 11.5, or we did the problems that came from 11.5 yesterday. Today, the rest of this quiz comes from 11.6. So that's what we're going to work on today. So to find the midpoint, we have two sets of plot points here. So it wants me to find the midpoint with using these two sets of points. And those sets of points was 3 and 8. And what was the other set? And a -7 and a 2. So what are my plot points? Or what is my midpoint on, let's say this is a line. What's the very middle of that line? Well, I use my midpoint formula. Midpoint's all the way over there. I'm going to take my x's. So I'm going to take x. I'm going to take 3 plus a -7. Then I'll divide it by 2. Do the same thing. I'm going to take 8 plus the 2, and then divide it by 2, and that will give me the plot point, or the x and the y, that's right in the middle of that line. So let's just assume this is a line. I don't know. It kind of looks like a line. So I have 3 and a -7. So my signs aren't the same. I'm going to subtract, take the sign of the larger absolute value number. So now I have 4, a -4 over 2, right? Then I have 8 plus 2, that's going to be a 10. I've gotten that far. But both of these are even numbers. Really easy to go ahead and finish them out. This will become a -2. I'm just dividing the -4 by the 2, getting a -2. And this will become a 5. 10 divided by 2 is going to become 5. So my midpoint between these two plot points is going to be -2 and 5. So that's the first one that you kind of have on your quiz. It kind of looks like that. The next one is asking me for actual distance. So let's look at your actual distance that you've got. Once again, they gave me some plot points, or some x's and y's, or some little points that if I'd been in a previous chapter, I would have just simply taken my graph paper and plotted those out. So what are my plot points? I have 4 and 9, and I have 9 and -3. And my question saying is find the distance between 4 and 9 and 9 and -3. And I'm going to use this distance formula that's over here, or the distance formula that's completely described to you if you don't have, if you can't see this, on page 459. So let's go ahead and set that up. I'm just going to go ahead and put all my points into this distance formula. So remember that when they're right here and they put x2 minus x1, y2 over y1, it really doesn't matter which one, which x you use first and which x you don't. It's just, all right, if I'm going to use the first x, then this, that better be the first x. If I'm going to use the second x, then that had better match up and be the second y as well. So that's what they're trying to tell you to do. Sometimes, they'll do stuff like that and you think, oh, I have to use this one. And not necessarily. But in the interest of, time, we'll do it just like the formula says. I'm going to go ahead and use the second x, which is 9. And I'm going to subtract the first one, which is 4. And that's going to be squared. Then I'm going to add that to the second y, which is a -3. And the first y, hold on here. I had an eraser and I lost it. And then I'm going to subtract the second, or the first y, that's the second y. Now I'm going to get the first y right there. Does that make sense? I feel like I'm blabbering now. So let's just make sure I've got it set up. So this 9 is is my second x, and I want to make sure that that matches the second y. See what I was trying to say? This is the first x, and I want to make sure that that's coming second, just like this one. It's the first y is coming second that I'm subtracting. Now you can revert those, you just always have to make sure you keep them in pairs when you're subtracting or adding or things like that. So let's do this step by step. So I have 9 minus a 9 minus a 4. That one's easy peasy, that's going to be 5. Eventually we're going to square that. This one is where we get into positive, negative numbers and we start to cross our eyes just a little bit. So I have a -3 and then I'm going to subtract a 9. Or what I could say is I have a -3 and I'm going to add the opposite. I'm going to add the opposite, which if I'm adding the opposite, that would be me adding a negative 9, which means this is going to become a negative 12. Kind of see what the concept is happening right there? All right, so we're going to go ahead and we are going to square those. This is going to, 5 squared is going to be 25. 12 squared, and this would become positive because, you know, positive 12 times negative 12 times a negative 12 would be a positive 144, and if nothing like that, we're still talking about length too. So that's going to be 144. I'm going to add those together. As I add those together, that's going to become a perfect square, which is 169. But you all may remember when we were going over perfect squares, hey, what would that be? That would end up becoming a 13. So my length between this and this is basically 13 units, whatever the units may be. So we have gone over 2 similar quiz questions. Let's go to your next quiz question. Your next quiz question is where we're going to go and use Pythagorean. Sorry, since 1986, I had an algebra teacher called it Pythagorean, and that's the one that stuck. Pythagorean. Let's use the Pythagorean formula. So on our next one, we know that the length of the unknown side of a right triangle, and we're looking for this unknown triangle. So I'm just going to let you see what we're doing. We know that the hypotenuse is 11. The hypotenuse is going to be the side that's over here. That's 11. We know that one of the sides is, or it actually says side A, is 2 multiplied to the square root of 10. So that's side A. A, C. What we're looking for is B. And so we're going to stick this into the Pythagorean theorem. So here we go. We have 2 to the radical of 10. Of course, that needs to be squared plus B squared equals C squared, right? But we know what C is. C is 11. C is going to be 11, and we're going to square that thing too, right? So we're going to square all of those. All right, this side's easy. 11 times 11 is 121. We still got this down. That's our unknown. This is the one where it takes a little thought of what actually is going on. Technically, me squaring the 10 is just going to pop out the number from that radical. And so it's just going to become 10. Hold on, let me write this a little bit smaller. So me squaring this is going to pop it out of the radical, and it's going to become just 10. But then I also have to remember that's going to be multiplied to this 2. That 2 is actually going to become squared. So it'll be a 4. So now I have 4 times 10. So this is going to become 40. Now I just have to solve for B. So how do I solve for B? Well, I'm going to subtract 40 from both sides. So subtracting 40 from both sides, I end up with B squared being 81. Am I done? No, I'm not. This goes back to this section right here, is I have to go ahead and put both of these sides under a radical. B just pops out, and the square root of 81 is going to be 9. Yes, technically it'd come out as positive or negative, but this is length, so it's going to be positive. So B is going to end up being 9. Now we're going to do a problem very, very similar to what's on your quiz, where we're going to use both distance formula, then we're going to have to plug everything we got in from distance formula into Pythagorean in order to see, is this a right triangle or not? So let's try all of these. So going over to distance formula, they give me 3 plot points. Why are they giving me 3 plot points? Because it's a triangle. So that's why, I've got to, You know, I've got a plot point here, one here, right? Don't know if it's a right or not. So I'm going to have to use distance formula 3 times in order to figure out what my sides of my triangle are going to be. So, and here are my 3 points. So one of them is at 7 and 11. Sounds like I need a big gulp in there. I have 9 and 15. And I have 11 and 14. We're going to use this 3 times in order to figure out the sides of the triangle, because we have 3 sides to a triangle. If you end up with 4, you don't have a triangle, you have a square or a rectangle. Or what's the other thing called? A rhombus? All right, so let's try these. So let's say just our first distance to keep up with it, so we won't kill ourselves, is we're going to have, we'll just say, let's use these 2 points first. So we're going to get that second x, and we're going to subtract 7. And I forgot to put the little, yeah, there's the squares. Then I'm going to add that to that second x, and it's 11. And then I need to square that. So when I do all that together, you can see this is going to be a 4. So hold on, I'm just going to write it out so we can get through here quickly. That's going to end up being a 4, right? I'm sorry, a 2. Then I'm going to square it, and it will be a 4. If I subtract this, that's going to be a 4. Then I'm going to square it, and that's a 16. So I end up with basically 20. Then I go all the way back to 11.2 and figure out, wait a second, there's actually a perfect square in there. Remember between these 2 factors, 4 and 5? So that would actually become 2 squared, or 2 times the radical of 5. So that's our first length. Our first length is that first one. Now let's go and let's measure or try to figure out the distance of those 2 points. So we're doing this point and that point. So doing that, distance 2, putting it all under here, we're going to have 11 minus 9, and then we'll square. Then we'll have 14 minus 15, then we're going to square it. This one is going to be a little bit easier. That's going to be a 2, right? And then I'm going to square it, so that's 4. This one's easy because it's going to be a 1, and then I square it, so it's a 1. So my distance for that one, and I don't have to break it down or simplify it anymore, is simply going to be a radical of 5. Then we have one more distance. So we did these two. Now we have to figure out the distance between plots 7 and 11 and plot 11 and 14, those 2 points. So let's do that one. So I'm going to have 11 minus the 7, and then we'll square. Then I'm going to have 14 minus the 11, and then I'm going to square it. Making sure you can see this. Are we here so far? Yeah, I think you're there so far. So let's look at what happens here. I will go ahead and put these two together. If we have 11 minus 7, that's going to be 4. Then I'll go ahead and square the 4, so that's going to be a 16. Then this one, 14 minus 11 would be 3. Then go ahead and square that 3, that would be 9. So that's going to end up being 25, which I would go ahead and take the square root of that, so it's simply going to be 5. All right, now, what am I supposed to do here? If I'm going to take these first two, because the way this one has been, they kind of set it up, is we're going to basically put all of, take these two, add them together, square them, add them together, and see if it comes up to be the side, or see if it's this other side squared, because that's what it ends up being. A squared plus B squared equals C squared. So I'm just going to stick it into that Pythagorean theorem. So on my first one, let's look and see what we got. So actually, I can just show you right here. You can see what we're doing right here. We're going to add this to this and see if it becomes the square of that. So let's see, all right? So I'm going to have 2 times the radical of 5 plus just the radical of 5. And I'm going to see if it's going to equal the square of my last distance, all right? And we're just going to see if that works. So C squared, and we'll just check it. So remember, both of these are going to be squared. Remember what we did the last time? Technically, what's happening here is the 5 is just going to pop out, but the 4 will be squared. So that is going to become 20. This one right here, 5 is just going to pop out, right? 5 will just pop out, and then I'm going to, yeah, it'll just pop out. There's nothing to multiply it to, so it just comes down right here. 20 plus 5 is going to be 25, and that's what C squared would be. Would that work? Look at what my third distance was. My third distance was 5. So, but see, C would be C squared. So look, yeah, that would work. So the short of it is, yes, this is a right triangle, because we plugged it into the Pythagorean theorem, and it worked out. So I can't pronounce it. I can somewhat do it. So we have gone over 4 quiz questions today. So from yesterday's lesson and today's lesson, you have all the quiz questions you need to know for the 11.5 and the 11.6 quiz, and you've kind of got an idea of what the radicals were. As far as yesterday we were adding subtracting radicals, and today we are using the Pythagorean, that theorem thing. So have a good rest of the day. Hopefully you can figure out your quiz. See ya.